Hi guys, this is Pender here. So making this video for you because in class the other day we talked about Pascal's triangle and binomial expansion, but we didn't quite get to the binomial theorem, and I want to do that now. So just to recap real quick, one of the things we spent some time speaking about was Pascal's triangle, which I think was the first time that a lot of you had seen Pascal's triangle, and it's really interesting. There's a lot of patterns in it. What we're primarily interested in doing with it is using it to expand binomials being raised to a power that might be a little unwieldy. So one of the last things we did in class was you worked with your groups, and we looked at, I believe, it doesn't really matter, I'll just pick one. I think it was expanding like x plus 1 to the, I'm going to go with 6th power. I think it was higher, but I'm just going to go with 6th. So we said to do that, using the patterns that we'd noticed, we would go to the 6th row in Pascal's triangle, and these numbers would represent the coefficients of the polynomial that I would get as a result of raising to the 6th power. And I know that I'm going to start with a 6th power as my first term, so this would be 1x to the 6th power, and then the powers descend by 1 as I travel across the row. So plus 6x to the 5th, plus 15x to the 4th, plus 20x cubed, plus 15x squared, plus 6x, and then finally plus 1. So we talked a little bit about the fact that this works because this binomial is very specifically x plus 1. And so the question is, what do you do to account for maybe a coefficient here of x, or maybe a subtraction sign, or maybe a number other than 1? And so I alluded to this thing called the binomial theorem. So I'm going to talk about that now. There's some notation here that's new, so just sort of like have some patience and pause and rewind the video as necessary to until you understand. And then, chat with your friends in the class and make sure you can understand. Here comes the binomial theorem. So it says if you take a binomial, say a plus b, and raise it to some power, it says that you can find the terms that are going to be the resulting polynomial expression by doing this. All right, this is called a summation symbol. It means we're going to add some things up. So what you're going to see, like up here, we added a bunch of terms together. So this is the summation symbol. And we are going to start with 0. So we write k equals 0 at the bottom of the summation symbol. And we're going to stop at some number n. So in this symbol, there's going to be an expression here in a moment. We're going to say, we're going to start with the numbers 0 all the way up to whatever number I've determined to be n, and we're going to add the things together. Again, bear with me. This sort of becomes a little bit clearer when you see an example. So I'm going to keep writing the binomial theorem. So here's the things that we're adding together. N, choose k. We looked at this in class the other day. And then a to the n minus k power times b to the k power. So I'm going to give you a minute to write that down, and I do want you to remember that we did discuss this n choose k thing in class the other day. We said it can take several different forms. It can look like this n choose k thing, or it can be with the big uppercase C. So remember that n choose k is found by doing this calculation, n factorial over n minus k factorial times k factorial. The first thing I want to do is talk about this a little bit more, because I want to show you how to get that number from the calculator rather than having to go through the process of writing out the factorials every time. So I'm going to do that in a second. Remember what I said the other day is that this can be written in different ways, this n choose k thing. And I said it could sometimes look like this and sometimes look like this. The variables differ depending on what book you look at or what technology you're using. So before we start with the binomial theorem, I want to show you on the graphic calculator how to make this happen. So I'm gonna go grab a calculator. So in class the other day, we practiced this process a couple of times. Hopefully my calculator brightness is like gonna be appropriate, hopefully. All right, we'll see how it goes. I'm gonna turn it up a little bit. All right, so for example, if I said to you, I would like to do 10 choose 6, or it could be written 10 choose 6, that would have been 10 factorial over n minus k, which is 4 factorial, times k factorial, which is 6 factorial. And so the 6 factorial would wipe out the 6, 5, 4, 3, 2, 1 up here, so I'd have 10, 9, 8, 7, and then I'd still have the 4, 3, 2, 1 here in the denominator. So let's see, I'll just like pop this in the calculator and see what I get. All right, so I'm going 10 times 9 times 8 times 7 divided by 4 times 3 times 2, and I got 210. So it's not like it's difficult, but it's a little tedious. So let me show you on the calculator how to do this calculation. So what you want to do is go to the math key, math, right there. And then we're going to go over to probability, and then you'll see the little NCR right here. So down to NCR. And then you're just going to fill your numbers in. So I'm going to go 10, and then if you arrow to the right, it will move you over to the other side of the uppercase C. And I'm going to put a 6 in there, and oh, look at that, 210. Okay, so we're going to use the calculator feature of that moving forward, but you are expected to understand how to use this formula. All right, I'm going to attempt to expand something using the binomial theorem. Here I go. Problem number 1. I'll start with something like this. X plus 7 to the 4th power. Now again, you could, crank through that algebra. I know you're all capable of doing it, but we're going to see if we can use the binomial theorem to do this. So here goes. So in this summation symbol, we always start with k being 0, and then our upper value n will be whatever the exponent is that we are using here. All right, so here goes. N choose k. So n is 4. So I go 4, and I'm starting always at 0. So 4 choose 0. Now my a value is the first part of the binomial. So in this case, the a value is x. So I'm going to put an x there. To the n minus k power, that's 4 minus 0, which is 4, times b. B is 7 in this instance, to the k power, which right now is 0. That's going to be my first term. All right, I'm just going to leave it like that for now. I'm adding stuff up, so I go next term. So the next thing I do, I started at 0, so now I'm going to use k as 1. So now this is 4 choose 1. My a value is x to the n minus k power, which is 3. My b value is 7 to the k power, which is 1. There's my second term. Okay, I'm going to keep going. I'm going to jump down here because I'm feeling like I don't have a lot of room right there. All right, so plus, here comes my next term. I had 4, 0, 4, 1. My next term is 4 choose 2. My a value, which is x, to the n minus k power. So that's going to be 2. And my b value 7 to the k power, which is 2. Hopefully you're seeing a pattern start to emerge here, right? It's always 4 because the exponent's 4. I start at 0, 1, 2. I have to keep going until I get to 4. So I have 2 more terms to do. Look what happens to the exponents. My a term, which in this case is x, starts at the highest exponent of 4 and starts to go down, 4, 3, 2. The exponent for the b value starts at 0 and begins to go up, 0, 1, 2. So I'm going to continue my pattern. 4 choose 3, x to the first power, 7 to the third. Here comes my last term. 4 choose 4, x to the 0 power, 7 to the fourth. Okay, now we got to clean this up because right now it looks like kind of a mess. So for the portion that's the combinations, we can use the calculator. So I'm going to go math, probability, NCR, 4 choose 0. So 4 choose 0 is 1. So this term here is 1 x to the fourth. Anything to the 0 power is 1. So this is 1 times x to the fourth times 1. So my first term is just x to the fourth. That takes care of that guy. 4 choose 1. So I go math, probability, 4 choose 1, and my answer is 4. So this guy is 4. X to the third and 7 to the first is 7. These things are being multiplied together. So this is 28 x to the third. That's my second term. Here comes my third term. I'm going to do 4 choose 2. Math, probability, 4 choose 2, and I get 6. So this is a 6. X squared. This is a 49. So I have to do 6 times 49, which is 294 x to the second. All right, I'm on 4 choose 3. Math, probability, 4 choose 3. I'm at 4 again, so this is 4. X, 7 to the third power is 343. Again, these are being multiplied, so 343 times 4 is 1372 x to the first. Okay, I'm on 4 choose 4. Math, probability, 4 choose 4. Hopefully this is a 1. 1, x to the 0 is 1, so it's gone. 7 to the fourth power is 2,401. Times 1 is still 2,401. So this is my expansion of x plus 7 to the fourth power. So again, feel free to like rewind, rewatch, pause, whatever you need to do. I'm going to do a couple more examples, but you want to make sure that you are catching on as you go along. So rewind as necessary. So that was problem number 1. So let's see if I can squeeze another one on this paper. Problem number 2. So I'm going to change up the a value. So I'm going to make this one like, I'm going to go with 2x plus 3y. I'm going to do this one to the 5th power, I guess. All right, here we go. So in the binomial theorem, my a value is going to be this 2x. My b value is going to be this 3y. My n value is 5. Okay, so it always starts at 0. So I'm going to start with 5, choose 0. 5, choose 0. Okay, first the a term, 2x to the n minus k power, which is going to be 5, and then 3y to the k power, which is 0. There's my first term. Plus, remember how this works. I start going up. I go up from 5 choose 0 to 5 choose 1. Now what's going to happen is this exponent's going to start to decrease, and this exponent's going to start to increase. 2x to the 4th power, 3y to the 1st power, plus 5 choose 2. If you want to pause now and continue the pattern and then hit play again after you've tried to see if you got the pattern right, feel free to do so. we're at the end. 5, choose 5. 2x to the 0, 3y to the 5th. So again, pattern looks like this. It's always starting at 5, right? I've always got 5 things that I'm choosing from because it's to the 5th power. I always start at 0, and it goes up 0, 1, 2, 3, 4, 5. Another pattern is that the a term, whatever the a term is, starts at the highest exponent and decreases 1 every time. So 2x to the 5th, 4th, 3rd, 2nd, 1st, none. And then kind of like to balance that, the 3y starts at the 0 exponent and goes up 1 every time. So if you feel good about trying to knock out this polynomial, go for it. I'm going to walk through it one more time. So you can either like watch if you feel like you need to see this again, or you can pause and try it and then come back and see how you did. All right, so again, we're going to go math, probability. Now, hopefully you're picking up on the fact that you get 1 every time here, right? And if you think about Pascal's triangle, that should make sense. I always have 1 as my first coefficient there. So let's see what I got here. This is 1. Now we have to watch our exponent rules here. 2x to the 5th, so I have to raise 2 to the 5th, and that's 32, and x to the 5th. This is 1 because it's to the 0 power. So my first term is, looks like 32 x to the 5th power. That's my first term. Here's my second term. 5, choose 1. So we go math, probability, NCR, 5, choose 1, and we get a 5. So this is 5. 2 to the 4th is 16, and this is x to the 4th. 3y to the 1st is 3y. This all has to be multiplied, so I'm doing 5 times 16 times 3, which is 240, x to the 4th y. Okay, here goes. Math. NCR. 5, choose 2. And I'm getting 10. So this is 10. This will be 8x to the 3rd. And this is 9y squared. Okay, so let's see. This 10 times 8 times 9, which is 720 x to the 3rd y squared. 5, choose 3. That's 10 again. 4x squared, 27y cubed. 10 times 4 times 27 is 1080 x squared y cubed. Plus 5, choose 4. Is 5. That's 2x. 3 to the 4th is 81 y to the 4th. So 81 times 5 is 405 x y to the 4th. And I have one more term that I'm going to try to squeeze in right there. So again, hopefully you're picking up on the fact that the last little combination is going to be 1. So this is 1. This is also 1 because anything to the 0 power is 1. So it looks like my last term is 3y to the 5th. And there is my polynomial. Hopefully that's all on the screen. Sorry if it's not. Okay. So I'm going to walk through one more, and like similarly, I think what you should do is maybe pause and try it, and then like turn the video back on and check it and see how you're doing. All right, so here comes one more example. Problem number 3. Let's see, let's make this interesting. So I'm gonna go with maybe like 3x squared minus y to the 4th to the 6th power. Okay, this is a good one. Alrighty, so let's just talk about this a little bit. So if you're going to try this, just listen to me for a minute, okay? So in my formula, a is going to be 3x squared. B is actually going to be negative y to the 4th. Negative y to the 4th. You gotta be careful there. All right, so negative y to the 4th is my b value. Okay. Be really careful and make sure you're following exponent rules if you're getting ready to try this one. All right, so go ahead and pause now if you want to give it a try. And here I go. All right, so it always starts off with your exponent and 0. And then it's my a value to the 6 minus 0, and my b value to the k. And here goes my pattern. 6 choose 1. This guy goes down to 5, and this one goes up to 1. 6 choose 3. Down to 4, and up to 2. 6 choose 4, down to 3, and up to 3. 6 choose 5, down to 2, and up to 4. 6 choose 6, oh, I'm dumb. I skipped 2. I'm going to have to go back and fix that. All right. Let's see. What's the easiest fix? I don't think I can just insert the 2 because then my exponents are going to be off. So I'm just going to like scribble these out. And if I had time, I would edit this video, but I'm just going to tell you that I'm probably not going to do that. I'm just going to say, hey, look, I made a mistake. Sorry. I'm going to fix it. Here we go. 6 choose 2. Forgot that one. My a value to the 4th and my b value to the 2nd. Okay, hopefully I'm back on track now. 6 choose 3. And I'm at 3 and 3. 6 choose 4. And I'm at 2 and 4. Now everything feels like it's lining up a little better. Like I could tell that something wasn't right there because I was getting to the end and I wasn't getting that 0 power that I was expecting. So let's see. So this is now 1. And this guy is 5. And here is what I was expecting to happen before. This is how I knew something wasn't right. I was expecting to get a 0 here and I wasn't because I dropped a term there. Okay, phew. Here we go. So, I'm gonna have some big numbers here, I suspect. That's all right. 6 choose 0 is 1. 3 to the 6th power, well, 3 to the 6th power is 729. And then power to a power is x to the 12th. This is 1. So my first term is 729 x to the 12th power. Okay. 6 choose 1. So I'm going to go math, math, probability, NCR. And I've got 6, choose 1. and that's 6. 3 to the 5th power is 243, and negative y to the 4th to the 1st is negative y to the 4th. So I have to multiply these together, so I'm multiplying 6 times 243, which is 1,458. It's going to be negative, so it's minus 1,458, x to the 10th, y to the 4th. So this negative sign, what this negative sign did is it caused the whole term to be negative. All right, I'm gonna keep going. 6 choose 2. Math, probability, NCR. 6 choose 2 is 15. So this is 15. 3 to the 4th is 81. Power to a power. All right, let's see what happens here. When you square a negative thing, you get a positive thing. So this is going to become positive y to the 8th. So this is plus 15 times 81 times, I guess that's it, 15 times 81. 1,215. X to the 8th, y to the 8th. 6 choose 3. Is 20. 27 x to the 6th, negative y to the 12th. So 20 times 27 is 540. It's going to be negative, and it's going to be x to the 6th, y to the 12th. 6 choose 4. Is 15. 9x to the 4th, positive y to the 16th. So 15 times 9 is 135. I'm going to drop down here because I'm not going to fit that there. 135, x to the 4th, y to the 16th. Next term's going to be negative. See how it starts to alternate? When you have a subtraction problem, you're going to get alternating signs. So 6 choose 5. Math, probability, 6. 5. And I'm at 6 again. This is 3x squared. This is going to be negative y to the 20th. So this will be negative 18 x to the 2nd, y to the 20th. This is going to be 1, 1, and positive y to the 24th power. And there is my lovely polynomial. Woo! If I made any mistakes, let me know. I clearly made one up there, but that one I caught, thankfully, and fixed before it had gone too far. All right, so you guys are going to do some problems. So you're going to get this pretty hefty worksheet with a whole bunch of problems on them. I want you to kind of jump around a little bit. Look at that. Woo! There's so much going on here. So here's what I think you should do. I think you should flip to the last page because this is where the expand problems are. And I'm gonna pick a few for you to do, and I'm gonna leave the answers with Mr. Denoncourt, who is supposed to be the one who's there, so hopefully that's who is. So I'm gonna pick a few of these for you to work on. So why don't we say, let's say on this sheet, let's do number, well, actually, oh yeah, well, they're in a weird order. All right, do them in this order, okay? Because I want to start with the easier and then move it up a little bit. So start with 81. So you can do that little guy right there. So that one's not too bad because there's not a whole lot going on. So do that one first. And then, let's see, maybe do number 77. That's sort of like a medium-ish one. Watch your signs there. And generally speaking, 77 has x's and y's, so when you have terms that have both x's and y's, usually you put them in alphabetical order. So even though the y term came first, try to put the x's in front of the y's. Not that it was not wrong, it's just, I don't know. reference, I guess. 77. Okay, and then maybe 86. I feel like I should put one more easy one in there at the beginning because some of these are a little tricky. Well, 75 is kind of dumb. You don't really need the theorem for that. So go back to the front page and do, what is 81? 81 was x plus 2. Do 14 first. Okay, so do this. Do 14, and then do 81, and then do 77, and then do 86. And actually, I have the answer key right here, so I think what I'll do is I'm just going to write the answers to those here. So don't look at the answers right now. I'll wait and do it at the end. I'll put them at the end because I want to say something else. Okay, after you do those 4 problems and check the answers, which will come at the end of the video, there's other problems on here. So here's what I'd like you to do after you do those 4. You're going to do those 4, and then I want you to think about some of these others. So, for example, number 5 asks, what's the coefficient of u to the second in this expansion? So I want you to think about that and ask yourself, like, can I answer this question without doing out the whole problem? Like, can you just pluck out the term that they are talking about? That's what I really want you to give some thought to. All right, and then same thing kind of down here when it says find each term, and I'll tell you which ones I want you to try in a minute. Try to do this without doing out the whole problem. So, you know, here it's like x plus 3 to the 5th. We want to know what's the 5th term. See if you can just calculate the 5th term based on what we've been talking about. All right, so I'm going to ask you to try, after you do those and check your answers, let's see, try, I guess number 1's a good one. Try like number 1 and maybe number 6. And then, how about, I guess 9. And then these are similar problems as you move down the page, but you'll see they get a little bit more complicated, or some of them at least, if there's multiple variables. So I'm going to have you try a couple of those. And same kind of thing. I want you to think to yourself, like, can I do this without doing out the entire problem? So it's like, let's try 29 and 28. We've got a ton of these, huh? All right. Let's see. How about 53? And 61 is a good one. And 60 is good too, and 60. Okay, so you're going to try those 4 problems, expanding them. You're going to check your answers, which I'm going to have up here in a moment. And then after you do that, you're going to go and you're going to try these problems without doing out the whole problem. That's your goal, right? So talk to a partner or, you know, a small group about how you think you could do that without doing the whole problem. All right, so that being said, let me write answers down here for these problems. So pause me now, go do these problems, and then come back. Okay? Bye. All right, so I'm gonna not give the answers for the other ones. We'll talk about that the next time that I see you. All righty. Have a nice weekend, everybody. Bye.